So now we're going to talk about these notes. So these notes right here, it just has several examples using the compound interest formula and the continuously compounded formula that can kind of help you, and it's going to give you different scenarios. So hopefully this will give you enough information where you can solve any type of these problems. Okay, so now let's look at the first one. Notice that I have all the formulas I need here. Remember, you only use this one if you hear the keyword compounded continuously. Otherwise, don't use it. Okay, so remember, I would say write what you know at the very least. It says if you invest, so that's money that you have, so that's the principal amount, that's how much money you started with. And if all this stuff doesn't make a whole lot of sense, make sure to watch the video before this. I believe that it should be before this, right? Essentially break this down for you even more. All right, so the rate is 7%. You have to write that as a decimal. And T is 10. All right, that's not going to change. The only thing that's going to change here is quarterly, daily, compounded continuously. All right, so the first two formulas are going to be essentially the same. And you want to know how much money you have at the end of it. Okay, so you would have 5,000. 1 plus 0.07 over quarterly. Okay, so that's going to be 4. Remember, N in this case is 4, which is how many times per year the interest is compounded. All right, all of this to the power of 4 times 10. Okay. And let's go ahead and write the formula for the next one. On the next one, the compounded daily, how many times per year you compound the interest? That's 365 times, because there's 365 days in a year. The formula is going to be pretty much the same, except for now we're going to have to change this to 365, and we're going to have to change this to 365. All right. Again, just make sure you look at the formula. Now, all I have to tell you about that is if you're doing this, make sure you use the calculator. Don't retype everything every time, because that's going to take you too much time. So let's just write the first one. We have 1 plus 0.07 over 4. Let's see, to the power of 4 times 10. Okay. So that's that answer. What I'm saying is if you already have this other one, just press the directional button up, highlight that one, just copy it and change those numbers. Okay, so those are your two answers for that, okay? Now I'm going to write it. I'm just telling you. On this one, I honestly just showing you on the calculator so you can do it faster. Because many of you don't have a calculator at home, so really in class, doing this in class is going to be like the only chance you get. Alright, so you got to be efficient at this. Alright, finally, if it's compounded continuously, you have to use this other formula. A is equal to PE to the RT, PERT, if you will. I don't like the name PERT. I think I just call it A to the PE to the RT. Okay, so compounded continuously. We're going to have to use this other formula, so we have A is equal to 5,000. E, R is 0.07, T is, what is T? 10. Okay, so again, I'm going to show you that one more time where the key is. Alright, so we have 5,000, type that in. That E key is right here on the natural log, so press second and press this button LN. Okay, so there you have it. Okay, so that gives me that much. And also notice that the difference between compounded daily and continuously is literally just less than $1, right? We're talking about just cents in this case, so it didn't really make that much of a difference. Okay. Alright, so on the next one, now we're going to talk about some other stuff that may be more difficult, right? It says, how much would you have to invest to have $5,000? So in this one, how much do you have to invest? That means that I don't know what P is. I don't know what that is. Alright, if you want to have, so A is 5,000. That's how much money I want to end up with at the end of it. The rate is 0.06 semi-annually. Semi-annually means that n is 2, so it's compounded twice, and t is 3. All right, so I'm going to plug all of that into the formula. So we have, let's see, 5,000 is equal to P, which is what I'm looking for, 1 plus 0.06 over 2 times 3. All right, I guess we can just write that as a 6. Okay. So remember what I said? I said this is pretty similar to what we did last time. This is just a number. All right, so I can plug all of that in the calculator and see what I get, and that's basically almost going to get me to the answer. So we have 5,000. Excuse me, not that. We have 1 plus alpha will equal 0.06. Let's make sure it is semi-annually. It is 2 to the power of 2 times 3, which is 6. Okay, so we have that number. So just copy that number down. We got 5,000 is equal to P times 1.194. Let's just leave it at that. Okay. So all we have to do is we're trying to get the P by itself, so we're going to divide both sides by this number. Right, and that's going to give us the principal amount of 4,187 and 42 cents. Okay, so that's the answer for that one. Well, the first component continuously is going to be the same thing. Now the only difference is that I'm going to use a different formula. I'm going to be using this formula. The only thing I don't know is P. All right, so we have 5,000 is equal to PE to the R, which in this case is 0.06 times 3. Okay. So just like that other one, this you just have to know is just a number. Okay, so this is the number. So plug that in your calculator, see what you get. Alright, so remember that second natural log for that. We have 0.06 times 3, so that gives us that crazy number. So we have 5,000 is equal to P times 1.197. And then we're going to divide both sides by this. So we would get P is equal to 4,176.35. Now, just please note that you have to invest a little bit less if you're compounding continuously, but I think the difference is pretty negligible. Okay, so now we're going to do a different type of problem where we're going to solve for R. So again, write everything you know, all right? I'm going to go through this one pretty quickly. This is going to be P is equal to 6,000. T is 12 years, so this is 12. A is 10,000. So I want to get 10,000 at the end of it, okay? Let's see. The charge for 12 years is not worth. Now, it says if you invested for 12 years, and notice that it doesn't really tell you what N is, and that's fine. If it doesn't, that's N is equal to 1, or don't even worry about it, because essentially what I'm going to have now is I'm going to have this formula. Notice that this formula and this formula are exactly the same if N is 1. If N is 1, then it becomes like this formula. So essentially that's what I'm using on the right. So now we want to end up with 10,000. I started with 6,000, and then we have 1 plus the rate, which is, what is the rate? Oh, that's what I'm looking for. Well, how convenient. Alright, so we have 1 plus R to the power of 12. Okay, and if you want to plug in 1 for N, that's fine. It gives you the same thing. Alright, so now this one I'm trying to solve for R. Alright, so remember, my goal is, kind of like we talked about it, we're going to try to isolate the term with the exponent. Alright, so we're going to divide by 6,000. you can write this as, let's see, I want to say that's 5/3, but oh, 1/6. Okay, did I write that wrong? I think I did, yeah. That's supposed to be at 10,000. So, forgot, add an extra 0 to that one. I knew something was up. Okay, so, yeah, we get 5/3. That's how I thought. Alright, so this is 5/3, and then we have 1 plus r to the 12th power. Alright, so the term is isolated. So now how do I get rid of this power? I need to get rid of this power. And don't forget that I can do it two ways. I can take the 12th root or raise both sides to the 1/12th power. Now in this case, I think for y'all, it's probably, you probably remember it like this better, but I could be wrong. Alright, so we're going to take the 12th root, or at the 12th root of each side. Now to do a 12th root, okay, you can either have 5/3, excuse me, let me write that as in parentheses, I kind of have to. We got 5/3, and then we can raise this to the 1 divided by 12th power, remember that? That's the same thing, right? 12th power, or that is, they're the same thing. So we get that, okay? Also, but if you want to put the root on there, if you want to do that, press 12, because it's going to be the 12th root. Go to math, and then go to option number 5. Okay, again, press 12, go to math and number 5, and that should get you there. Alright, so, and this one I don't really need parentheses, so it should give me the same thing. Alright, either way, however you do it, doesn't matter. Okay. So now I have that this right here is 1.043 is equal to 1 plus r. And then at the end of it, I'm just going to have to subtract 1. So my answer is 0.043. That's the rate, which is about 4.3%. Okay. Alright, so on this one, they're asking you the same thing, but it says, what continuous rate? And actually, that's kind of a weird question, but I guess we're still looking for R. Okay, so if it was the same idea, but just we're looking for R here, we're going to use A is equal to PE to the RT. Okay, remember that's continuous rate, means you're going to use that formula. So same idea, everything's about the same. Alright, so we have 10,000, let me really write 10,000 this time, is equal to 6,000. E to the power of R, well, RT, which is going to be 12, R times 12, or 12 times R. Right, same idea as before, we're going to try to isolate this guy first. Alright, so we're going to divide by 6,000. That's going to give me 5/3. This is going to give me E to the power of 12R. Now on this, and it comes back to what we talked about a few lessons ago, if the variable that you're looking for is a power, and this one is, you're going to have to use a logarithm to get rid of that, to get rid of this E. Now remember, the inverse of E is the natural log, so I'm going to take the natural log of each side. Important to note that if I take the natural log of this side, I can actually move this 12R in front. Okay, so we have the natural log of 5/3 is equal to the natural log of E, they cancel, and you end up with 12R. Right? Don't forget that. And I can move this 12R in front, and maybe I should at least write it so you can see it. That's what I'm doing first, and then this right here is 1. It cancels out, so all I end up with is just this, which then finally I'm going to divide by 12, and that should give me the answer. Alright, if you plug all this in on the calculator, I actually don't know what that is. Should be about the same, I imagine, but let's just do that. We have the natural log of 5 divided by 3 divided by the natural, divided by 12. Okay. So, pretty close. If I round the same, R is going to be equal to 0.423. I would have kept rounding, I guess I would have come up with a different problem. Anyways, that's it. Let's go ahead and move on. Let's look at other problems that are different. Okay, so on this one it says, how long should you invest? 100, blah, 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 blah. Anyways, you can probably read that yourself, but it's up here, so maybe I should move it down. Okay, excuse me. So on this one we have all of this. Okay, I'm going to go ahead and assume you can read. Big assumption, I know. .05. Okay. So let's plug all that in. So I have 250 is equal to 100. And remember, I'm using this formula, in case you're wondering. Especially since it talked about compounding interest quarterly, right? So I'm using this formula, in case you're wondering. So we have that 1 plus 0.05 over 4 to the power of 4t. Now notice, I'm going to try to isolate this one first. Isolate that guy. Alright, so we're going to divide both sides by 100. When I divide this by 100, I get 2.5. And if you want to, and there's nothing wrong with it, you can actually put the 1 plus, let's see, 1 plus alpha y equal 0.05 divided by 4. You can put that in and get a number for that. In this case, that's 1.0125. So all of this is the same thing, and again, I divided by 100 first, in case you're wondering how I got the 2.5, okay? And then this one is going to give us 1.0125 to the power of 4t. Alright, so that power right there, I want to get rid of it, right? What I'm looking for is in the power, so I'm going to have to use a logarithm to try to get that down. So I'm going to take the log of both sides. In this case, it would be easier just to take the log base 10, just because that's the key on your calculator. Okay? But it turns out that really any logarithm you use will work. Okay, so remember the power is here right now, but I can, by the properties of logarithms, I can put that right there. Okay, and that's really the most important thing. That's the whole reason we use this logarithm. Alright, so now I'm trying to get t by itself now. So I'm going to divide both sides by the log of 1.0125, and that would cancel this, right? So we have the log of what is it? 1.0125. And then simultaneously, I'm going to divide this by 4. You don't have to do it simultaneously, but I mean, at least you can do it all in one step. So t is equal to whatever this quantity is. Now, don't skip any steps on here. You're down to the easiest part, which is plug it into the calculator. So we have the log of 2.5. Oops. The log, remember that log key is right here, right by that 7. So the log of 2.5 divided by 4. Notice that I'm basically typing it exactly like I wrote it. Okay, so there you go, 18.44. So it takes about 18 years, almost 18 and a half years, right? Okay, so there's that. Okay, so if it's comparing continuously, it's almost the same idea, so we're going to plug it in. Remember, compounded continuously means I'm going to use this formula. PE to the RT A is equal. Everything is going to remain the same, except for obviously I don't have a space for n is equal to 4 because this is being compounded continuously. Anyway, so now, what do we got here? So we got 250 is equal to 100. E to the power of 0.05 times t. Okay? And we're trying to solve for t. So one more time, I'm going to try to isolate this one right here, the term with the exponent, with the exponential part, I suppose. So we start off by dividing by 100. So you get a 2.5 is equal to e to the power of 0.05t. Now, on this one, here's the deal. You can actually take the log of both sides just like it did on the last time, but I know that the inverse of e is natural log. So I'm going to use a different log, a different base, I should say. So I'm going to take the log, the natural log, excuse me, of 0.05t. Now remember, this is as a power, and by the rules, or excuse me, the properties of logarithms, I can move that in front. 0.05t. Okay, so that's gone. All right, here's the big deal about this. All right, so yes, that was kind of nice. I can divide both sides with the natural log of e, but the natural log of e is 1, so that one's gone. All right, so all I have left now, I'm going to rewrite it so I don't make a mess of this. We have natural log of 2.5 is equal to 0.05t. All right, so I'm going to divide both sides by 0.05. So t is equal to 18.33 years. All right, so that's how you do that one. Just if you're trying to get rid of the e, just use the natural log and instead of just the log base 10. All right, so that's it. All right, if you see a problem where you have depreciation, all right, the only part that's going to change is this. You're going to have a minus there. So for example, in this one, all right, I'm going to go straight into this formula. The car is worth $25,000, so P is this. Depreciates at a rate of 13, so R is 0.13. What is the value in 7 years? So T is 7. Notice that this one doesn't have any compounded interest or anything like that, so we're going to go straight into this formula or this formula. So again, if you start with some amount of money and you end up with less money, then that something is depreciating. Okay, so in this case, since they didn't talk about any compounded interest, then we're going to use this one. Or you can say that n is 1 is the same thing. So we're going to go ahead and use that one. So we have $25,000. 1 minus 0.13 in 7 years. And if you plug it in your calculator, plug it in exactly like you see it, is 943.14. And that makes sense, right? If you buy a car, normally, not all the time obviously, but normally the car doesn't gain value the longer you have it. It actually loses value as the longer you have it. All right. So now we have something called population growth and decay. Now in this one, if we have population, for example, this one is the population is decreasing. All right. So we're going to use this one that has a negative because it's decreasing. And notice that it's decreasing, even though it doesn't say, it's decreasing continuously. Okay. So we're just going to use this. Now notice that it says, how long until you have half? And it doesn't give me much information other than the rate. So this is 0.005, right? If I move that decimal twice, that's 0.5 right there. So, okay, I don't know how much I have, but I know that at the end of it, I'm going to end up with half, right? So A is going to be 1/2, P is going to be 1, okay? And then E, well, E doesn't change, R is 0.005 negative, and I'm looking for that. Okay. Not too terribly bad. So now all I'm going to do here is I'm going to take the natural log of both sides. So I have the natural log of 1/2 is equal to the natural log of E 0.005t. Remember that this part, and I have white and I have yellow paper. No, it's not, it doesn't work very well, but I'm going to bring that over here. So we have negative 0.005t. Okay, and the natural log of E is 1, so that cancels out. So I end up just with the natural log of 1/2 is equal to negative 0.005t. Okay, so on this one right here, I'm just going to divide both sides by this. And at that point, I'm hoping that that gives me a positive number. Alright, so we have the natural log of 0.5 or the natural log of half. Oops. Natural log of 1 divided by 2. You can write that as 1/2 or 0.5, it doesn't matter. Okay, so we have 138, which I can only assume are years, 0.63. Okay, now it says how long after you have the triple population? Well, this one doesn't actually, it's not decreasing population. On this one, you would just use PE to the RT So let me do this one real quick. So if we have 3 times, that means that this is, P is 1, E is the same. I'm guessing the population is the same. It doesn't really say, but I'm guessing that's what he wants. Okay, so same idea. We're going to take the natural log of each side. When I take the natural log of this, I end up just with the power, just like I did the last time. And I want to divide this. I'm guessing that's going to take forever. Now, this is assuming that it's increasing, right? So it's the same type of problem. Natural log of 3 divided by 0.005. That's going to take a long time. So T is equal to 219.72. Well, hopefully that wasn't too bad. I hope you're getting a little more comfortable with the natural logs and E's, but